Hi friends, today we are going to discuss about a new topic, Nernst distribution law, coming in the first solubility chapter in physical pharmaceutics 1. So what we want to know from that is what is this law, what are the applications and limitations. You will get a question how to write a note. So first we have to clear what it is. So the same practical aspect what we are doing in the practical lab, that thing we are going to execute based on what principle, how we are performing the experiment. So the Nernst distribution law, that idea was given by the scientist Nernst in the year 1891. So this law will give an idea about the relative distribution of a component that is soluble in two liquid mixtures where the liquids are either immiscible or miscible to a limited extent. So indirectly we are telling about the partition coefficient. So what we are telling is that actually this based on this Nernst distribution law, we are performing the partition coefficient, or the other name of partition coefficient is distribution coefficient. So that is the basic principle behind this partition coefficient experiment. So based on the solute or solvent ability, so we are calling the part of the solution as solute and solvent. So if the mixtures, if you are doing components are immiscible, or if miscibility is less, in that case we are thinking about this distribution law. So first of all we are going to tell about how it is dissociating when it is moving, how it is moving to an organic phase or to an aqueous phase. So if it's a strong electrolyte, what happens is that in the organic layer it will come as a monomer, and in aqueous layer there's a tendency to dissociate if the component of your mixture is a strong electrolyte. So the dissociation can be expressed by Kd. So we can tell like that the monomer concentration in the organic phase divided by total concentration in water raised to n, where n means the number of molecules solute will undergo dissociation. So that thing only we are dividing in the partition coefficient experiment, organic phase divided by aqueous phase. So we are renaming the strong electrode, let it be Ha. So it will undergo dissociation. So Ha, as per chemical equilibrium under dissociation, it will become an A minus ion plus hydronium ion. And on this equation, if you apply the laws of mass action, so we can tell what is dissociation constant for that particular strong electrolyte. So whatever it is, if you are finding to find a component, how you want to find is that whatever you are writing in the right side divided by the left side portion. So this right side will become the numerator part, and second the left side become the denominator part. So how we can write the Ka is equal to concentration. So we are multiplying the concentration of the right side divided by multiplying the concentration on the left side. So the equation Ka become hydronium ion concentration into A minus ion concentration divided by Ha concentration, and we are not neglecting the water part. So we can tell like that as per dissociation equation, the hydronium ion concentration is equal to A minus I. So on that concept, if you are putting this thing on this equation become like this. We are telling both are equal, right? So hydronium ion concentration square divided by Ha. So if we want to find out the hydronium or the strong electrolyte concentration, when we are cross multiplying, we get hydronium ion square divided by Ka concentration. Again, we are telling like that as per the distribution law, Ha if mon that our strong electrode is going to the organic phase, we can write like that dissociation constant is equal to Ha into organic phase divided by aqueous phase, and if you are substituting the HAW in the above equation, we will get like this Ka into C1 by hydronium ion concentration. So instead of that, we are telling the hydronium ion concentration, let it be C2. So we substitute instead of this hydronium ion concentration to C2. So we'll get like that dissociation constant by as a dissociation constant is equal to C1 by C2 square, and we are telling this Kd by K, whatever constant should be a constant. So as per modified distribution, we are telling Dissociation is equal to, or distribution is equal to, monomer concentration in organic phase divided by concentration in the aqueous phase raised to n. So that is the derivation part. If it is a weak electrolyte, the distribution will undergo like this. So we are telling C0, Ca, let A and B, it will undergo dissociation. Then again like that. So what happens is that the if this is our solute, it is having a tendency to go or distribute between the organic and aqueous layer. So this is another part of derivation, how the organic phase like that. Let the Ha be the acid but water. So applying the law of mass action and degree of dissociation, we will get dissociation constant is equal to C0 by Kw minus X. So we can define distribution law which help you to determine the relative distribution of a component that is soluble in two liquid mixtures. We have to mention either it should be immiscible or miscible to a content. So you can write the value like this. So we can represent partition coefficient by capital K. If K we are getting greater than 1, that solute prefers organic phase. If we are getting K less than 1, we can tell like that the solute prefer aqueous phase. So we can tell with any of the example what you have done in your lab, like benzoic acid and benzene water, as per the thing it can explain the procedure for the distribution law. So again we are stating Nernst law like that when a solute is added to a mixture of two immiscible liquid in an amount insufficient to saturate, what happens? Added substance having a tendency to distribute between two solvents so that the ratio is a constant at a given temperature provided the molecular state of the distributed solute is same in both the phases. Again, we are telling K distribution coefficient, the partition coefficient is equal to C1 by C2, where C1 represents the concentration of the organic phase divided by aqueous phase. So instead of C1 by C2, we can write organic phase by aqueous phase. And distribution of the solute between two immiscible liquid phase at a constant temperature is known as the distribution law or partition coefficient or distribution coefficient or distribution ratio. So telling about the limitation, it is a temperature dependent. If it is particular temperature only, we can depend on the distribution law. Second thing in is that if it is an ideal condition or ideal dilute solution only, we can apply this distribution law. And the solute should not undergo any change in its molecular state, but it is impossible. In that case only we can tell that distribution is accurate. As well as we cannot determine the lipophilicity properly, and we have to see the partition solvent, then only we can go for the thing. So this partition coefficient or distribution law is having number of application. So we can use for the partition coefficient concept for the separation, purification, identification part. And this principle only we are using in the prolonged release for the sustained release preparation. And this distribution law we are applying in the dissolution of an insoluble or sparingly soluble drug any product by micellar solubilization. We can use the same concept in preservative action. It will help to improve the absorption of a new chemical entity, as well as it helps to determine the degree of hydrolysis of the salt in the aqueous solution. So this is the application. Hope you will get a clear concept about the distribution law. If you find useful, please share to your friends. Thank you for watching. Have a nice day.